Our focus is on factorizing to simplify algebraic expressions.
Looking at a basic example of the common factor. 7x squared y minus 14x to the power of 3. The common factor is when we are seeing in the terms that there is something that we can extract, something present in both. Now, generally, you want to try and take out the biggest possible common factor. So between the numbers, 7 is a common number. So I'm going to extract that, divide it through. And then between the variables, x raised to the power of 2 is the biggest one. Then, upon doing division, see what's left. 7x squared y divided by 7x squared. It leaves me with y. The product gets me back there. And then keep the sign. 7 goes into 14 twice, and then we're lacking an x. So that's a basic example of the common factor. Here is an example of a more complex one. Between the numbers 1/5, 20, and 5, I'm going to pull out a fifth as a common factor. And then amongst the letters, there is an x at least in all of them. Now, complete it to see what you need in order to get back to the original, so to say. Into a fifth is fine. To go from x to x squared, you're needing an x squared and then the y to follow. How many times can a fifth go into 20? So that's what you need to ask. If you're not sure, what you can do is say 20 and then divide it by the factor that you're pulling out. So that's a fifth. So what that tells me is the number of fifths goes into 20 100 times. So you're going to have minus 100. X we've pulled out, so I'm left with y raised to the 3. And then I'm going to do the same process here. How many times can a fifth go over here? So a fifth goes into 5 25 times. Now, because we've got x and x here, it goes into itself once, so we needn't write it. Between the terms, term 1 and term 2, we might not see a common factor per se, but I see an identical set of brackets. Here's one bracket and here's another one that are exactly the same. So as we're getting common factor, we're going to pull it out to the front. So I'm going to pull out that a minus b and then see what I'm left with. When I pull a minus b out of term 1, I'm left with 5a squared. And then when we do the same thing in the second one, when we pull this division, then we're left with 4. And that's how the common bracket works in a basic case. Sometimes it's not as straightforward, where we may need to do some manipulation. So for instance, I can see that there's so much potential between these brackets, okay? They're not identical yet, but let's first do the swap. Swap the terms around. Because you can see here's the a first, but here's the b term first. So I'm going to do this. I'm going to swap the order. So I'm going to put the minus a and then the plus 3b at the back. Now remember, the sign always belongs with what's behind it. So this minus belongs with the a, and this is positive, so it has to stay like that. Can you see they're almost identical now? All that's different is they differ by a sign. So now you've got to pull out a negative. So let's say you extract the negative term. I'm going to do that. If I pull a negative out of this term, I have to do so in both of them. So if I want this to look like a minus 3b, 3b, that negative has to go somewhere. So what it does is it affects the sign of the term as a whole. So this positive 9 changes to a negative 9. That enabled me to change the signs within. Now, learners, can you see that the brackets are identical? So we extract the common bracket. So we pull out the a minus 3b, and then we are left with what's remaining once those brackets have been factored out. So that's 25a squared minus 9. The dots example, difference of 2 squares. So it has to meet these criteria. So what we do is we construct 2 small brackets and we square root everything. Square root of 36, square root of x, square root of 25, and then ask yourself, to obtain a difference, what happens to the signs? We need a plus and a minus. Now the more complicated one looks like this. See, does it match the criteria? Difference, 2 squares. So we construct our brackets and we root everything. 100 is 10. M to the power of 4 can be obtained using the m. M squared and m squared yield m to the power of 4, and then n to the 3 and n to the 3. Same base, add the exponents gets me back to n6. And then this one, a plus b squared. It is a perfect square. So to root it, the square would fall away. So this would be a plus b, and then the minus is obtained through a plus and a minus. I often see this style of question asked in an exam, and students just use their calculator or they panic because they haven't done it in class. 29 squared minus 19 squared. Notice, is it a difference of 2 squares? Difference of 2 squares. Yes. So it follows the same structure. Root everything. 29 squared, the root of that is simply 29. Because 29 times 29 is 29 squared. And the same for 19. 19 and 19. And then a minus is obtained, plus minus. Okay, so you can do it like this, and then you can actually find an answer should you be required to do so. 29 plus 19 is 8. And then 29 minus 19 is 10. And then 48 times 10, 480. Should you be required to get a numerical answer to that. Trinomials, 3-term expression as explained in one of our previous videos. It conforms to trinomial structure because it's 3 terms and it's in decreasing powers of x. So here it's going to be 2 brackets. Generally, when the coefficient of the first one is 1, so there isn't a number present, it's very simple. So you can just take x squared and then root each of them like that. And now we need to establish a pair of numbers which will give me a product to 12 but a summation to 7. So the numbers here would be 3 and 4. Because 3 times 4 is 12, but when we add them, it's 7. In both instances, it's a plus, so both of them are going to be plus constants. Now, in grade 10, we introduce an A factor. So that is when we have a coefficient here. So once again, going to have 2 brackets. But now the pairs might not be as apparent. So I'm going to use a little process called the T1C. I usually use this when I teach my students in our face-to-face classes. So T1C. Term 1, constant. So our term 1 is 8. What pairs make 8? So we've got 1 and 8, 2 and 4, 4 and 2, and 8 and 1. So listing all of the factor pairs. And then the same thing for our constant. 1 and 6, 2 and 3, 3 and 2, 6 and 1. Now, by trial and error, you've got to cross-multiply them to obtain the middle term. Just for reference, 1 and 6, when we multiply them, it's 6, and then 1 with 8 is 8. Now, 6 and 8 can never combine to give me 13. But what about if we try 1 with 3? 1 times 3, I'm just going to identify it. 1 times 3 is 3, and then that same pair, 8 and 2, that's the next step. The product is 16. Now, can you see? 16 and 3, we can manipulate that to get 13. So that's perfect. To get 13, that's a plus, and this has to be a minus. And then we bring the signs back. The positive 16 came from this pair. Put that positive in. And the negative came from this pair. And now you've got to read this horizontally into the bracket. Okay? So this is going to be 1 H. And this one is going to be 8H. And now for the constants, so the 1H goes with the plus 2, and the 8H goes with the minus 3. New form of factorizing in grade 10, it's the sum or difference of cubes. It's going to follow the structure where we have a small bracket and then a bigger bracket. Now step 1 is, into the small bracket, you've got to cube root everything. So step 1, cube root everything. The cube root of a to the power of 3 is a, and the cube root of b cubed is b. The sign stays the same, okay? So if it's a minus in the question, it's a minus in the first bracket. Then to move into the second bracket, you have to square it, square each of these to obtain the term 1 and term 3 value, okay? That's why this is a big bracket. A squared is a to the 2, minus b squared is plus b to the 2. And then the third step is to obtain term 2, which is the middle term, right? You have to find the product of the initial bracket, and then you got to negate it. So a times negative b is minus ab, right? Minus ab. Now just negate that. So minus with minus ab is going to be plus ab. Okay, there we go, guys. So if you've enjoyed this video and you've learned something from it, you may want to check this one out next. A like and a subscribe will help us to grow our channel, and feel free to share this with any of your friends so we can all achieve academic success together. See you in the next one.